Hello, everybody. Welcome and thanks for joining today as we talk about video probes and analytics. My name's Tom Ward. Just before we get started, and I'll introduce you to the rest of the panel today, I want to just do a little housekeeping. So just make sure that you look around in your desktop area. This workspace can be managed by you. You can move things around as you see fit and just kind of explore the area a little bit. Secondly, I want to let you know that anytime you want in that, there's an area where you could request a demo. So if you see something you like or just want to have a demonstration of our equipment, you can go ahead and set that up right from the panel here. Just a reminder, we have an upcoming measurement webinar coming up in a week or so. You can go into the resource page here and you could get yourself registered for that if that's what you'd like to do. And then we had a user workshop, kind of tricks and tips for Mentor Visual IQ a couple of weeks ago. That is now on demand and available if you'd like to review that. What else? So if you have any questions, please submit them in the question box that you'll see on your screen. We will get to those at the end, so don't worry. We'll try to answer all the questions that we can. If we were able to run out of time, we'll certainly send those out as well in the on-demand version. And then lastly, if you wouldn't mind, there's a survey. So please take some time to fill out the survey. Let us know what you thought about this information. Let us know what you want to see in the future, how you might want us to do it differently. We're happy to take in that information and try to modify what we're providing to you so that we best meet what you're looking for. Okay, and so with that, we'll go and introduce our presenters today. I'm Tom Ward. I've been with this business really in the RVI business for over 30 years. Currently a senior product manager here at Waygate Technologies, managing the Mentor Visual IQ product line. We also have Sheldon McCracken on our team. He manages our software team here in Skaneateles and has a lot of information to share with you around these analytics. He did a lot of work there in his previous roles. So great content expert to have here. And then Tom Danvers, who has been an inspector in the aviation business for over 20 years, deep domain knowledge, and is now managing the software part of our business here at Waygate Visual. So hopefully you'll learn a lot from these guys today. They are super smart. And then if I just talk a little bit about our agenda here, just going through it, we're going to talk about kind of what are analytics, kind of demystify what these things are, how they're used in the world today, kind of all over the place, really. Sometimes you won't even know they're being used. Challenges and advancements around artificial intelligence. We'll talk a little bit about that. And then we'll pivot over into how these sort of fit into the remote visual inspection world, share some use cases in RVI currently, and then lastly, we'll do a live example. So we'll go into the engine that we have here in Skaneateles, New York, and share with you a live example of how some of these analytics work. When we're doing that, by the way, I'm just letting you know, I'm sitting at an engine here in Skaneateles, New York, right in the back end of where our factory is, and so they're busy building the video borescope. So if you hear any background noise, that's just them getting these video probes ready to ship out around the world. And with that, I am now going to turn it over to Sheldon McCracken, who will kick us off today. Thanks.
Yeah, thanks, Tom. So I'm going to start with what are analytics, and I'm going to stay pretty high level today. If anyone has any technical questions, feel free to submit them in the chat, and we can answer those towards the end. But at the highest level, analytics are the application of computer science and math to discover some patterns in data sets, right? So there's data all around us. You'll hear terms big data. Analytics are really trying to make some meaning out of that data and allow you to take some actions. Specifically today, we're talking about image-based analytics, which you may sometimes hear called computer vision. And I wanted to talk a little bit about some examples of image-based analytics that you're familiar with, that you'll see on your everyday life, right? So one of the more popular ones these days is self-driving cars, right? And there's a lot of technology that goes into self-driving cars. It's not just image analytics, but image analytics is one thing that feeds into it. So in this slide, the picture on the left, you'll see a simulation of what a self-driving car could potentially see. So you can tell here that it's able to to detect and localize items that are in the scene, as well as classify what those things are, right? So it's able to see that there is a number of pedestrians on the right-hand side of this, the kind of the field of view. There's some cars in front of it, and then there's some stoplights are the things that it's currently detecting. And then there's intelligence and analytics built on top of this that allows the car to figure out, okay, now what should I do or what should I not do? There's pedestrians on the right side, so I shouldn't go right. There's cars in front of me, so I need to be careful, maybe potentially put on the brakes, do things like that. Some other examples that you use in your everyday life is Face ID, right? I think almost everyone probably has a smartphone that you unlock probably hundreds of times a day with Face ID. So that's something that you set up once and you kind of set it and forget it. But that's an analytic that's almost always running on your phone. A lot of the more recent doorbell cameras have analytics in them that allow you to detect when there's been a package delivered. So sometimes you'll get an image, a notification on your phone that has an image of a package and maybe even has a box around the package and says, hey, I detected a package and here it is. And then the last example here is one thing that I think is pretty cool on most modern smartphones, again, is in your Photos app. If you go into search and you just type in a keyword, right, dog, cat, whatever it is, it will pull up examples of dogs that you've taken pictures of or that you have pictures of on your phone. You didn't go in and label all of those images as dog and tell your phone that those were dogs, but it knows that those are dogs, right? And it also groups people together and does various things. So these are all examples of image-based analytics that you interact with, in your everyday life. So one of the, this is what, modern analytics give us. There's a lot of challenges and advancements recently in AI, artificial intelligence, that have allowed some of these things to come to fruition, as well as what we'll be talking about later with analytics on borescopes. I'll start with some of the challenges that have kind of the industry has faced over the past several years, right? Kind of historically, and then I'll go into how advancements in AI have solved some of those challenges, right? So the idea of computer vision isn't new. This is a technology has been around for a while to look at images and try to determine what's in them. But we've had these problems for a long time, right? So when you look at an image, you see something like the face on the top left, right? You see some pixels and some shapes, and you have context of what that is. What a computer sees is a list of numbers. So each pixel has an associated number with it. So if it's grayscale, it's just one number. If it's an RGB image, which is what's shown below, it's 3 sets of numbers for each pixel, right? And that's really all a computer sees, right? So a computer has to figure out, okay, how do I take these numbers and make something out of that? So that's the first challenge, right? Is a computer really doesn't have the context that we have. The other challenges, and there's several of them, but 4 other examples are things that, like variations in viewpoint, right? If I look at the statue of a cat, I can tell almost immediately that that's the same physical object, right? But to a computer, that looks quite a bit different. Maybe the bottom 2 kind of look similar, but the top 2, those look quite a bit different. So there's challenges there. There's challenges in illumination, right? Is it a bright or dark scene? Is there no color at all? There's challenges with obstruction. So you see the dog here in the drawer. You can't really, we know that's a dog because we have context, but to a computer, it's hard to pick out that that's the actual subject that we're interested in, the dog. And then, the background challenge here on the bottom right, that's actually even pretty challenging for a human if you just quickly glance at it, but there is a person standing in front of that stack of logs there. So these are some of the challenges that exist in the computer vision space, in the image analytics space today. And while we have made advancements in solving many of these challenges, we're still pretty far away from a general purpose seeing machine, which is quoted here at the top. So we've got a ways to go there, but we are getting much better at, individual applications of computer vision. So some of the more modern advancements in AI are things you'll hear called like deep learning or neural networks. And really, what that means is instead of saying I want to look for a specific feature, a curve, a circle, a straight line, or a change in color pattern, we say, hey, I want to look for some context in the image. And the way we do this is we teach a neural network what things are. And I'll talk a little bit more about what that teaching process looks like. But this really kind of mimics how our brains work, and that's why it's called neural networks. So in the top right, you see an image of an actual neuron. And then right below that, you see a mathematical representation of a neuron that's used in the neural network. So, in your brain, you have various signals that come into the neuron. Those are inputs in a neural network. So that could be the numbers that make up the image that I was talking about previously, right? RGB values. Those all get summed up together, go into some activation function, and then there's an output that goes to the next neuron, right? And that's very similar to how your brain works. And there's hundreds of thousands of neurons that make up various neural networks. And what these neural networks do is they allow us to generalize well compared to the traditional methods of computer vision. So those challenges I was talking about earlier with obstruction or variations in viewpoints, these neural networks allow us to get around some of those challenges. Now, the downside of this is we have to teach these networks what they're looking for. And the way we teach it is we show it a bunch of examples. So the same way a human learns, right? When you're a kid and you're growing up, you learn by experience, and you take in a bunch of data and you learn over time, and your neural network, your brain, is learning things. And that's the same way these neural networks work. So you'll hear the term training in a model, training an analytic, training a neural network. That's what we're talking about here. I've got a little animation here that shows kind of what that training process is doing. So the very first set of neurons that you're seeing on the left are the set of circles. That's actually the image represented by those pixel values I was talking about earlier. So in this example, we're just looking at images of hand-drawn numbers, right? So you see this number 1, you see the number 5, loops through various numbers. And what we do is we give this model, so this is a small representation of a neural network, we give it a bunch of these numbers. And then we go through this training process, and the model learns, okay, what does this activation function need to be, and what are these weights? And I'm generalizing here. This could be a 2-hour topic alone, talking about neural networks. But at the highest level, we learn what these neurons should do in the network and how they should interact with various inputs. And when we get to the end, you'll see an output layer here, which is the numbers 0 through 9. And so as these are lighting up, that's saying, hey, I'm predicting that number. And we go through this iterative process and we train the weights in this network, and the individual neurons in this network, and we get some model, right? And that's our analytic. And then when we go to use this analytic in the next animation, you'll see the number 7 goes through the network, and it's been trained. So when it knows which neurons need to light up when it sees this type of input. And then you get an output of 7 here at the end. So the model is pretty confident that this hand-drawn image is a 7. So like I said, there's a lot of technical details here, and we could go way out in the weeds on this, but I'm trying to keep it pretty high level today. But this is how, in general, neural networks work. And with that, I'm going to pass it over to Tom Danvers to talk about how these analytics fit into RVI.
Thank you, Sheldon. Hello, everybody. My name's Tom Danvers, and just a quick thank you from me for taking time out of your days to join us on this webinar. I'll be bringing the conversation down to the boroscope level, and first really wanted to sort of introduce the notion of, obviously, why is it we think it's important, we as Waygate think it's important to have this discussion and have this technology inserted into our borescopes today. To fundamentally, I summarize it as the 4 words on the top line in order to aid today's inspection tasks. We acknowledge what you do and how you use your equipment takes a lot of time. A lot of information is gathered, and a lot of decisions are made based on the information that you're presented and the information that is being generated on the borescopes. We recognize that the borescope has a significant processing power, and with recent advancements in the code upon which analytics are generated, we now have the ability to really start focusing on the ability to incorporate artificial intelligence, or as we term it, analytics, into the borescope. So yes, I just have a number of bullet points here, really just to sort of highlight the fact that why is it that we think it's important? So fundamentally, we believe there's appropriate sort of benefits associated with saving a large amount of time in your normal day-to-day work or workflows that you're undertaking on the borescope. To name one of them, for instance, is associated with labeling. So we'll be going through examples associated with how to obtain sort of simple annotated and labeled images very, very quickly. Focusing on tasks that are perhaps tedious and very high in frequency, such as counting blades. So we've incorporated the ability to perform that activity automatically on the device. Again, we'll talk more about that in the future. Also, as we see on the 3rd bullet point, there is feature recognition technology that we're exploiting. So blade tip clearance is one of the measurement types that we have had on the borescope for a recent number of years. And we'll talk a little bit more about that in terms of feature recognition and the artificial intelligence associated with enabling that to take place. Improving POD, probability of detection. We understand that really these devices are primarily there to perform very important, very critically based, sort of maintenance-based inspections associated with making sure that your industrial assets are operated in accordance with accepted limits that they're designed to operate within. So making sure that you have the ability to detect small defects or defects of interest and subsequently make decisions based on that is very important. So improving POD basically enables you to improve your ability to detect even smaller defects than you would otherwise be able to. And lastly, that you see here is the word ADR, or the abbreviation ADR, assisted defect recognition. So we'll be introducing you to a new form of inspection in terms of the capability that we now have on our device. As Sheldon, you've heard as outlined, we now have the ability to operate analytics on the device, not connected to the network, purely on the standalone device, being the MVIQ. Before I move on to subsequent topics associated with the more detail about what you see here, I kind of just wanted to pause and take a few moments asking you this question. Before we talk more about analytics, what are the top 3 qualities that you most value in your borescope system? So please do select up to 3, please, out of these options that you see associated with the features and the capabilities that we have on today's borescope. I'll be shortly sort of closing the question and revealing the answers in a few seconds. We just need the top 3. Is it the image quality? Is it perhaps the digital enablement, the movement of data, for instance? Once all that data has been generated, it has the capability of generating reports, for instance. Out of all those options, which are most important to you? And if you think there's one that is important, or the most important that isn't listed, by all means click on the other and type that into the Q&A, and we can touch on that towards the end of the session. Okay, thank you very much. Yes, clearly it's quite profound that this is a device that's a high-end, world-class leading industrial videoscope system. So camera and image quality is profoundly important to you all, and that's completely understood. Secondary is once you've captured an image, what then you do to that image, and obviously measurement and subsequent decisions based on the measurement of that artifact is very important. So thank you very much. Very good. So at this point, I'm just going to share my screen and take you through the rest of these slides. So analytics and working with our boroscope. So here is a slide that outlines the points in which boroscope inspections are carried out on the MVIQ. Boroscope inspections are carried out on engines. This is an example of obviously an industrial asset. I'm taking, the gas turbine aero engine as an example. It could be all sorts of other industrial applications. So I'm picking up on the example associated with the aero engine. What you see on the slide is sort of two sections: the section inside the dotted box and the section outside of the dotted box, associated with the creation and assembly of a new engine and attaching it to the airframe before it then enters into service. What I've done here is kind of highlighted the significant steps or points in the life cycle of this industrial asset, the aero engine in this case, where a large amount of effort and time and resources put into inspecting it and establishing the condition of the engine. So I call these kind of generically as a front to rear inspection, where upon the full sort of gas stream of the gas turbine in this case is inspected. That includes all stages of the compressor, combustion chamber, and subsequent turbine stages. So we recognize that before it enters into service, a lot of effort is establishing the sort of the base condition of that engine before dispatch to the airframer, upon which subsequent inspections are done at the airframe and pre-delivery stages. So these are understood to be very important processes to establish the condition of that engine. And when into service, we understand that there are various events upon which subsequent inspections are done, most of which are planned. For instance, those that I've highlighted here as MRO or maintenance, repair and overhaul shop visits. There are a number of shop visits across the life cycle of this particular, this type of industrial asset, the aero engine. And there's a series of unplanned or unscheduled arisings that take place, whereupon certain conditions environmental issues or operational issues arise that mandate the subsequent inspection of that engine. So these are time-consuming, sometimes planned or not planned arisings where the inspection of the engine is mandated. And what we mean by mandated, it's a heavily regulated industry, so it's important that these inspections are carried out in accordance with either the engine manual or the aircraft maintenance manual. So the front to rear inspection, just kind of put it into context, I kind of added up the number of blades associated with, in this case, a CFM 56-3, which happens to be the engine behind Tom Ward when you heard him talk through the introduction. So there's, over 1,500 1,500 aerofoils upon which most of them are comprised within the compressor, and 700 in the turbine. So what you see here on the video on the right-hand side, if I just play it, upon revealing a defect that might appear in the screen, what we have here on the analytics, we have the still assisted defect recognition analytic. What we see here, by tapping the screen and entering to the freeze frame state, the user is presented with a bounding box And this is what we have, an artificial intelligence associated with, in this case, an Air Innovations analytic that's trained, that includes this RB211 engine that you see here. By applying a defect classification, in this case a NIC, it's very easily, very rapidly able to highlight and label that and save that image within a few seconds, as you see here. And by rotating it slightly, you can see another sort of indication arose, and you have the ability to accept and reject those indications. Indeed, manually add some if need be. So as an example, whilst doing a front-to-rear inspection, it's you can have a defect recognition analytic that's trained on the engine type that you're inspecting, which we have now available on the boroscope, to enable you to, once you find a defect, you're able to, let me just play that whilst I continue talking, to rapidly detect and label that. Okay. Label that image before you can carry on with your inspection. You recognize that it's a very time-consuming task. It can take well up to the time of one shift pattern, for instance, or even more if that engine contains a lot of defects or artifacts that require subsequent capture, measurement, and sentencing. So ultimately, we understand that it's not all about detection and categorization or labeling. It's necessary to be able to measure and understand the location in order for you to be able to then be able to make a decision with regard to sentencing. But here, what we're showing you here is a trained analytic, much akin to what you heard Sheldon talk about earlier, associated with training of defects, in this case, on an aero engine. And this is now available to you all, and in this case from Air Innovations. We as Waygate have generated other analytics on the device. We'll talk about that in a moment. Here's another example of using artificial intelligence that actually recognizes the component within the scene. So not to do with defect recognition. This is recognizing an aerofoil and the associated shroud liner, or abradable liner. And then by activating a measurement type, in this case blade tip clearance, the device rapidly detects and calculates the various depth measurements across the chord of the blade and presents that in a text box that you've just seen on the screen. So this was sort of set up such that there's an auto repeat function that we now have on our device. So it becomes a one button sequence where by pressing that one button, in this case, the blade tip clearance measurement is automatically calculated once acquiring a 3D phase measurement image. So what would take many, many seconds to acquire and perform a depth measurement and manually assign the cursor points is performed very rapidly, as you can see in this video sequence. Therefore, saving a large amount of time and removing a large amount of subjectivity and repeatability associated with manually assigning cursor points. This is all done automatically now by the device. Wanted to sort of put into context analytics on the boroscope. We have an immensely powerful MVIQ platform. As we move around this slide, as we move around from the 9 o'clock position and rotate clockwise, we kind of touch on features and technologies associated with acquiring the signal associated with doing the inspection, basically capturing and video recording the footage associated with the object or the components that you're inspecting. We utilize a lot of features associated with not just in-house technologies, but also being able to ensure that we are compatible with third-party devices. So I'm picking up on the turning tool, for instance, connectivity here. So we have the ability to be able to communicate with and receive signals currently from the turning tool and be able to generate images, whether they're flat JPEG optical images or stereo measurement or 3D face measurement images, for instance, before the turning tool then rotates and that sequence is done again and again. So there is this sort of relationship that we have in this case with the turning tool. As you know, that we have founded sort of technology on our optics, on our image chain that we have developed in-house within Waygate Technologies. So we have developed a range of very highly powerful, high definition camera CCD chips associated with generating the images that you're used to now operating with on the MVIQ. And as you move around, we've got the ability to perform inspections under a prescribed workflow. Again, so that you're able to sort of save a lot of time, remove a lot of subjectivity associated with the inspections that you yourself are doing and your colleagues on the shift associated with, in this case, again, the inspection of a gas turbine, taking you through prescribed stages and labeling and categorizing and file naming in a repeatable, clear, concise way. All to do with saving time and improving your productivity. And as you move around, we talk about stitching as well and real 3D measurement. So I was kind of putting analytics in the context of all of the capabilities and technologies that we now have on the devices. A new feature associated with the MVIQ ecosystem. So analytics really focusing on your ability to analyze the scene. Once you've captured, acquired, you're really able to sort of perform analysis and then make decisions associated with that analysis and perform sort of an act associated with sentencing and making a decision based on that information. So yes, so now this is the point where I'll move on to a live demonstration with my colleague Tom Ward over in the Skinnyattalis facility.
Perfect. Thanks, Tom. Really nice job there. Appreciate all that content and expertise. I'm now going to share my screen, and we'll pull up the live view. Hopefully, everybody can see what I'm going on here. We'll wait till that little bar disappears. And then, hey, so an inspector could do everything on the product, as Tom mentioned there. So that's awesome. And there's lots of very well-trained inspectors out there. But on the other hand, if you have a situation where you want to have some expertise from somewhere else, or you just want a second opinion, as many of you may know, we have software we can connect called InspectionWorks Connect anywhere around the world. So in this case, my colleague Tom Danvers sits over in the UK today, and he is now connected to me. And so what we'll do here is I'll have him kind of walk me through what he wants me to do as an expert that is going to help me try to decide if we have a problem here. And we'll use ADR as that example. So carry on, Mr. Danvers.
Thank you. Thank you. Right, let's begin the rotation. So Tom, as an inspector on our CFM 56-3, he's hooked up to an electronic turning tool and is rotating the HB spool. It's looking inside one of the HB compressor stages. So as Tom rotates, what we have, as you can see on the top right-hand side of the screen, we have an LM2500 Assist-L analytic activated. So as Tom was rotating, thank you, Tom, if you just pause there for a second, maybe just roll it on a little bit more. So what's happening here on the screen is, as you heard Sheldon explain at the top of the conversation, top of this webinar, what we have is an artificial intelligence-based analytic, defect recognition analytic, in this case trained on 4,500 images associated with various defects associated with gas turbine artifacts in the LM2500. And although we're presenting this analytic to a CFM 56, you'll appreciate no doubt that a compressor blade in one engine type is very similar to those in other engine types, and so too are the defect types. So as Tom was rotating, he's kind of just stopped the analytic, or stopped the rotation as the defect analytic suddenly presented what you see on the screen here. So Tom has activated not just the indication box, but also the defect classification. By factory default, we have the yellow border present itself to the user. And if you turn on those settings, which Tom has done here, you also get not just the bounding box, but also the label associated with it. So what we have is a nick. You'll appreciate perhaps this is an artificially created nick that you see on the screen. But as Tom rotates just a little bit more, you'll see that bounding box and label follows the defect. This is a live assisted defect recognition analytic that we now have on our boroscope. So if you just stop there, Tom, and then tap the screen, so you move from the live to the freeze frame state. So you see on the top left, it says now FF. Tom now is also presented with essentially the same bounding box. So if you tap the toggle and enter page 2 of the soft keys and press review indications, there you go. Tom's got these options associated with what you saw in a previous sort of clip that I was showing in the slide deck. You can accept, reject, or indeed add an indication. So if you were to just tap approve, because we believe this is a genuine defect, and then go into edit, if you could just tap edit for me. So we could change the indication and change the shape of it, but if you went and tapped edit classification, if we wanted to change that classification to some other type, those are the list of available defect classifications for this defect recognition analytic. We can't add or subtract any of these. These were the labels associated with those images that I told you about earlier, in terms of that those were the ones containing these defect classifications that formed the 4,500 images that was the trained and labeled images that created that. So if we wanted to, we could just demonstrate by changing it from dent to nick to crack, for instance. If you just tapped on crack, and then you'll see the label change accordingly. Just to satisfy me, let's go back to dent and nick, and then if you could change it again for me, Tom, and then you can just save the script, save the image. So it's a very quick, obviously we took a little bit longer to get into the save point, but it's a very quick process associated with finding a defect and then entering the freeze frame state and then labeling it, making sure you're happy with the label before saving it. So if you go back to the live state, please, Tom. Yep, so as you continue rotation, thank you, you'll see that blade move off out of the field of view. And what you'll see, that indication detected border, the yellow border on the screen, and any bounding boxes disappear. And the live analytic is still operating in the background. Again, you see the bounding, the info box on the top right-hand side of the screen, letting everyone know whether it's an image that you save or video that you record. It's known to the viewer of that information that a defect recognition analytic was active. And then you see underneath that a toggle associated, or a number associated with a number of indications of defects or anomalies that were found within that given frame, for instance. So the other thing that you see on the screen, I haven't really talked about it until now, is the blade counter. So you'll see blade 56 illuminated or presented here on the screen. So this is another analytic that we have on the device. So as you continue moving or rotating, Tom, you'll see, if you haven't already focused on that box, if you keep returning, there we go. This is a blade counter, and this is also trained based on artificial intelligence. And presented with lots of videos from all sorts of different gas turbines, from different views, different illumination settings, different speeds, and obviously different stages of all sorts of different engines. So it's trained on the ability to detect the edge of aerofoils entering and leaving the given field of view from the borescope. So if you were to just pause briefly and just tap the image soft key, please, Tom, and press blade counter lines, there you go. What you'll see on the screen is the setup associated with that analytic. So as you continue rotating, you'll see the edge of the blade coincide with the two vertical lines that you see on the screen. So what's happening is as the edge passes by the blue line, the analytic is triggered to say, this is an edge of the blade. And as it passes by the central sort of green cursor, that's the trigger point. And that's the point upon which the blade count is triggered, and it either goes up one or down one, depending on which direction you're wanting it to count. So that is a feature recognition analytic that we have that again is operating in the live state. So as you're doing the inspection, by all means have that feature turned off. We have the toggle there available to you, the users, because if you were to sort of nudge and change the position of the borescope in relation to the blades during an inspection by having those re-illuminated on the screen, you're able to sort of reposition that borescope and continue using the blade counter. So it is currently necessary to ensure that probe is fixed in position. So using the blade counter and setting it up and operating it is done once you're happy with the view and you're happy to do that rotation within that field of view. And you're able to sort of, as you move back in the other direction, if you just demonstrate that, Tom, it counts up and down. It is bi-directional. And if you wanted to, you could change it from blade 8, as it's showing at the moment, to some other blade number without having to stop it and start it again. So there's all sorts of fun.
Just taking up some slop in the gearbox, so that's done now. And now it's, as Tom stated, we can move the other way.
Yeah. So all sorts of settings associated with not just the blade counter, but the defect recognition analytics. One thing I didn't actually mention was when we were showing earlier the nick, the artificial nick, we have the ability to filter out defects. So if you were presented, for instance, and you were doing an inspection on, let's say, the HP turbine blades and those blades were thermal barrier coated, there could be the setting or the arising of lots of bounding boxes being presented to you associated with TBC loss, for instance. And the filter enables you, as Tom's just showing you, enables you to basically filter out chosen defect types. So let's say TBC loss is activated. If you could do that, well, actually, maybe if you filter out the dent and nick, and as you get to the dent and nick, Tom, we can show that dent and nick is not presented. So yeah, again, all about making sure that you can focus on the task at hand. If you wanted to filter out one or more of the defect classifications, for instance, what you heard me talk about TBC loss when you're doing an HB blade inspection, you can not be distracted by all of those bounded boxes associated with that chosen defect type, and just focus on the ones that you really perhaps are most interested in. Let's just say cracking and and tears, for instance. So yes, blade counter really helps you focus on the inspection itself. Labeling and annotating can be a very time-consuming process, especially if you're having to do that for every blade type, blade that you're presented with. If you're having to save images for each and every blade that you're inspecting. Understand in some facilities that is a requirement. So again, it's a reliable tool. There we go. There's a dent passing by or the nick passing by, and you can tell that it's not illuminated or detected by the analytic, and you're reminded that it's filtered. As you can see in the top right-hand side info box, its dent and nick is removed from the. There we go. I'm going to put it back on. Okay. And it's represented. So that's live assisted defect recognition that we now have available to you on the borescope. It's essentially designed to work in conjunction with the still state as well as the live state. So once you've detected and found that defect by using this analytic, you then enter the still state and can interact with those bounding boxes. Indeed, create new bounding boxes manually or interact with the ones that are presented to you by the analytic in terms of rejecting them, and accepting them. What that means is when you save that image, when you load that image back in, it only presents the ones that were accepted, for instance. So any false positives associated with any debris or dust, for instance, that might be picking up as a defect, you can reject those. It's important to say that anything that is rejected, should we say, at this stage, but the image is still saved, those rejections aren't deleted from the image, they're just not presented. So you have the ability to re-illuminate all those indications if you wanted to offline in the recalled state on the borescope, or indeed via the inspection manager software, and ensure that you, or perhaps your colleagues, perhaps you're a supervisor to inspectors or something like that, or just the inspector, if you wanted to change your mind, for instance, you have the ability to re-illuminate the different defects that were perhaps originally rejected. Okay, thank you, Tom.
Another poll question you're going to put up for our audience.
Yes. So if you just cancelled your borescope screen.
You're back.
Yep. So we're nearing the end of our hour, but we just wanted to squeeze in one more poll question if we could. We wanted to really ask you, whilst you've now heard us talk about analytics, what analytics would you like to use today if they were available? So you've heard me talk about defect recognition. What's most important to you? Please tick as many boxes as you see fit that are important to you and your business and to your job. Is it counting blades? Is it perhaps doing automated measurement? Perhaps analytics can help you negotiate from one surface to another surface at one point in the engine to another, for instance, navigation, for instance. So it doesn't have to be just defect recognition, for instance. Perhaps you might want an analytic to help you in labeling components, for instance. What's important to you? Please just tick the appropriate box, and we'll just give you a little bit more time before closing that. And if there's one that I've not presented, but you have that one that's important, please tick the other and then submit that into the Q&A, into the chat, and we can pick that up on the conversation that we'll have shortly. Okay, thank you. Thank you for all those responses. Measurement, defect recognition, counting, and navigation. Very good, thank you very much. Okay, I'll hand over to Tom now. Thank you very much. That's all from me. We'll now go through your Q's and A's.
Yeah, and Tom, we may need more from you with some of the great questions we had. So we'll do some Q&A now. I'll pick out a few of these. Got a whole bunch, so that's really good. Maybe the first one here I see to Sheldon or Tom. Can MVIQ ADR, so assisted defect recognition, can that control a turning tool to help position the indication on the screen?
Right. Shall I talk through that, Sheldon?
Yeah, it's up to you if you want to. Go for it.
Yes. Currently, the answer to that excellent question is no. We want to be able to do exactly that. We recognize coupling this technology that you heard me talk about with regard to defect recognition with a compatible turning tool, and be able to control and stop, for instance, and then start, a turning tool, is not something that can happen today. Very much want to make that happen. So watch this space, I'd like to say formally, and see what we can do to make that happen in the near future.
Yeah, thank you, Tom. Another one, did the tip to shroud, we showed the tip to shroud measurement in your video earlier, Tom, and you talked a bit about that. Was that activated by the ADR or the inspector? Is the question. Right.
So the inspector captures the 3D. What you didn't see in my demonstration was I activated a 3D phase measurement image, and then tapped auto repeat to on, and then tapped the blade tip clearance function. There's like 8 or 9 different measurement types that you'll appreciate perhaps when you activate a measurement on a 3D phase measurement generated image. And so it was me that activated the blade tip clearance. And because I had auto repeat turned on, all subsequent 3D PM image taps on the screen automatically went to blade tip clearance function. So I basically told the borescope that every time now I'm going to want to do a 3D PM capture, I want it all to be directed through blade tip clearance. So it was me that did that. So the artificial intelligence part of that conversation was that the device recognizes the tip, and it recognizes the shroud liner, and then performs a series of depth measurements associated with those two surfaces, and presents the results in that box that you saw earlier about min, max, and average values.
Hey, Tom, so, and another one, maybe Sheldon can take this, or you. We're being asked, when will these analytics actually be able to take the job of the full measurement, right? So we're being presented with a defect. We want to measure that defect in some way. And so that the analytic just grabs that. And if we want it to, it does the whole thing for us. So we just watch the process kind of as a macro. Is that something that you see in the future?
Yeah, so that's a really good question. I would say, we're working on things like that. So Tom talked about, we just showed blade tip clearance measurements, and that's a part of auto measure, right? It places the cursors for you. We have similar things with depth measurements where we can find the deepest point. So we've, these things aren't new, but we're continuing to improve on them and combine the technologies. So to your point, we do envision a future where an analytic can detect some type of defect and then prescribe a measurement and maybe auto place some cursors and then prompt the user to adjust those as needed. We're not quite there yet. There's some challenges that we're working through, but that is something that we envision becoming a product.
Yeah, thanks, Sheldon. Another question around similar topic: how much data, whether it's images or videos, how much data is needed to allow you to continue to improve ADR performance? So whatever the baseline is today, I guess there's 2 questions, right? How much do you need to build the baseline, and then how much additional information is used or needed to improve that capability?
Yeah, that's another really good question, and the answer is it depends, which is not a great answer. But like Tom mentioned, for the existing LM2500 model that you shared, it was trained on a data set of, I believe, like 4,000, 4,500 images, and that sets up a good baseline, right? But as I mentioned in the kind of the technical portion of this at the beginning, the deep learning or neural network approach does benefit from more data. So the more data that we can feed these models, these analytics, the more accurate they'll become over time, right? Especially when you start thinking about defects that you don't see very often. So we had a pretty big artificially machined nick in the example today. So, we're able to detect that pretty well. For really small defects or defects that are unique, right, in the way they present themselves, that's really where having more data comes into play, because we're able to get a broader view of what these defects look like, right? And you can even think about this, and I mentioned how humans learn, right? If you see something that you've never seen before, as a human, it takes you a minute to really put it into context and figure out what it is, right? And you have to have some examples of that before you know what it is. So that's similar to how these analytics work.
Yeah, thanks, Sheldon. Another one for either of you. So what we showed live was the assisted defect recognition, both the live and the still analytic for LM2500. Question one, does it work with the other variants around that engine type? So I'm thinking about LM5000, LM6000. And then second part of that question really is, how do we, Waygate, decide which, in this case, the question asks about engines to develop models for, but I guess I'd expand on that question because, remote visual inspection is not only aviation, it's not only rotating equipment. And so how do we think about other inspections that are needing to be done and how we can help with ADR in the future?
Yeah, by all means, you can follow up after me, Sheldon. But why we developed what we have today was basically we had access to a substantial image library containing LM2500, predominantly, not exclusively, but predominantly LM2500 images from the compressor, combustion chamber, and the turbine. So the 4,500 value that you heard us talk about wasn't just compressor blade defects and images. Don't forget, we also have to train the model of images that contain no defects as well. And so it's important that we're training the analytic as to what is normal as opposed to, in addition to what is not normal. We want to be able to make and it is validated on the LM2500. We understand the LM5000 and 6000 variants are extremely similar in appearance. They differ in size and stage number predominantly, although there are some other changes in the combustion chamber, for instance. So it will no doubt work in those other variants. It's not validated in those other variants. But you'll see here our demonstration, for instance, was not on an LM2500. And I've exposed it to other arisings on other RB211 based engines as well, for instance. And it's, yes, there are the normal sort of defects that you see in one engine type are very similar, if not exactly the same as the defects that you see in other engine types. So we call it as we have done because it was validated on that engine type. So we're wanting to, now that we've just been talking about sustaining a model and enhancing it, we do want to build it with and train it with images of other types, and we'll either create different models or enhance the existing model so that the applicability of this model increases over the course of time. So access to data and labeled data is important to enable us to make that step forward.
Yeah, just to add, if there's anybody out there that has a particular inspection that they're interested in learning more about how ADR might help them, please reach out to us. I know we're getting close to time here. Maybe just two more questions. I'll take one of them myself on can you measure crack length? I think is what the question is. I'll just say yes, absolutely. Our product has the most capable measurement technology in the world. We have a measurement, I'll take a time to say again that we have a measurement webinar coming up where the inventor of most of our measurement will be on along with Mr. Danvers here to talk about just those things. Secondly and lastly, maybe Mr. Danvers, there's another question on how do I know how to pick the right lens for the job, right? So I have these choices of the tip optics that I can put on my video borescope. How do I choose the one I choose? And maybe we'll wrap up after this question.
Yeah, there's lots of, just to follow up on in your resources section on this webinar, there's lots of other answers to questions that are also contained in these documents called data sheets. So by all means, please download and review the data sheets. But that's one of the questions raised in the data sheet for the LM2500 analytic. Essentially, the answer in short is it was trained on images that were derived or created by different tips and indeed different borescopes. and different diameters. So currently we do not, it is not sensitive to the different tips, whether they're different focus tips and even phase measurement tips and stereo tips. Stereo tips, I think, actually can be an issue in some instances, but yes, all of the different sort of normal tips and phase measurement tips, it is insensitive to those types.
Thanks, Tom. And then lastly, there's a few more questions here we didn't get to. We will answer those and provide those answers out to the audience, so you'll be able to get your hands on that. And then I also, on the question of which tip optic to use just in general, I think that's a great subject. If folks on the line think that's something we should spend some time talking about, we could set up a webinar like this to kind of go through those areas around cameras and tip optics and fields of view and depth of fields and so forth around both measurement and standard tip optics. So thank you, everybody, for being on the call today. Please, again, let us know if this is the kind of content you'd like to hear about. Tell us in our survey. Tell us what other content you'd like to hear about. And again, thanks for everybody. Thanks to the presenters today. And hope you all have a great day, morning, night, depending on where you are in this big. Goodbye for now.